We've already alluded to step 7, so this won't take very long. Basically, once you've figured out your critical and endpoints, you can compare them to figure out your extreme values. For example, 1, we're trying to figure out a box of maximum volume. And so all we have to do is look at the biggest value that occurs between our critical points and our endpoints. We make a chart of our two endpoints and our critical point. We can easily see that if we make the box base 6 of length 6 feet, then it will produce a maximum volume of 108. Since a absolute extreme value can only occur either at a critical point or an endpoint. Step 7 is to determine the absolute extrema by comparing your endpoints and critical points. Again, if we go back and look at the picture here, x will be equal to 6 feet, and that will produce a maximum volume of this open box. So, we're close to the end, okay? Again, we want to make sure we answer the question thoroughly, but for right now, you can get a pretty good idea what the answer is going to look like. Now, the units for that are going to be cubic feet, but we'll talk about that later. All right, let's look at the next example, step 7. Again, we want to produce a minimum total area given 10 inches of material with this equilateral triangle and square. We found out the endpoints right here and the critical point here. The independent variable being x, which is how long the triangle is, side length, and then area would be the total area once you take into account the triangle and the square. When we compare those for step 7, we can figure out what the absolute extrema is, in this case minimum area. And again, that middle value, which is our critical value, will produce a minimum area of 2.718, or approximately E. So a triangle side length, let's zoom out here a little bit. A triangle, zoom out a little bit more so make sure you can read that. So a triangle side length of x equals 1.883 produces a minimum total area of 2.718 square inches. Okay, and again, in terms of this picture, we're saying that if x is equal to 1.883, then the total area of both of these is going to be just a little bit more than 2.718. We try the endpoints, that's going to give us a bigger area. If x is 0 and it's all square, it's going to be 6.25. If x is 3.3 repeating and there's no square, it's going to be 4.8. So we will choose the critical point for step 7, and that will determine our absolute extrema. All right, let's look at step 7, for example 3. Again, we're trying to maximize profit on this apartment building. What rent maximizes monthly profit? So we found our endpoints to be 1,000, 26,400. If we charge 1,000 for rent, that's how much we're going to make. If we charge 2,200 for rent, we'll make 0. Our critical point, if we charge 1,160 for rent, we will make 27,040. Putting that together in step 7, we can quickly see that our critical point, if rent is 1,160, we'll make the most amount of money. We'll make $27,040 a month. So that is our absolute extrema for rent. And that's it for step 7. We are almost done with optimization. If you have any other questions about this step, let me know.